kind of, okay, so we're gonna just review the different parts. So going to this one cylinder, there are 3 parts to this, 3 surfaces, the top circle, the bottom circle, and then the side. But it looks like there's only 2 in here, right? The 2 pi RH. That's the side of the cylinder. That's the one that kind of goes around. So this is my water bottle. This is the 2 pi RH. And then the pi r squared, that's a circle formula. So that's pi r squared is a circle. And you notice that there's 2 at the front because you're just gonna double it up. That's for the top, the bottom and the top. So those are the formulas that we've seen in terms of surface area. Now, we're gonna talk about volume. What's the difference between volume and surface area? Surface area is what this is on page 30. Surface area is what you could feel on the surface, on the outside, okay? Now, volume is in the inside. So how much stuff can you have inside the 3D shape, okay? So they're slightly different. Some questions, they will say, calculate the volume of this shape, okay? They're very straightforward. Sometimes when we come across some examples, they're gonna ask it, how much water can you put in there? Well, remember, water is on the inside of the shape, so we're looking at the volume calculation. If you have a basketball or a beach ball that you have to, blow up, right? So that it's full of air. The question might be, how much air is inside the basketball, or how much air is required to blow up a beach ball, right? So that one calls for a volume, because the volume is what's in the inside. Huh? They're different. Yeah, the formula are different. Yeah. So the difference, you're actually going to get a formula sheet for the test, for the exam. And this is what, we haven't quite finalized everything yet, but this is what the formula sheet is going to look like. Okay? So this is what the formula sheet that you're going to get look like. And let me zoom it in a little bit.
Will we get the formula from the
Yeah.
first until the end, or only from
No.
this?
You will get, this is the formula sheet that you're going to get, kind of similar to this. It will have the formula for the area. Okay, area. You got the circumference formula. You don't have the perimeter formula, but because you just add them all up, right?
No, what I mean is for all units.
Oh, no. The only formula that you're gonna get from the formula sheet are the measurement formula, measurement unit formula, like surface area, volume, all these stuff. And you're gonna get this formula.
How about this?
That one, yeah, I'm gonna show it to everybody. This one, I think it's gonna be okay to bring that, because that's really not quite a formula.
Yeah.
Yeah, if you wanna bring that to the exam and you have it with you, please bring it. This is not part of your formula sheet. This is just a calculator instruction. Yeah, we're gonna allow you, okay? I think all teachers of applied will allow you to bring that, okay? Well, Bisham and I will do that, okay? And I still have some extra just in case you don't have it anymore. Yeah, so you're gonna come across going back to Anja's question, she says we have 2 different formula in here, which one is which? So surface area, this is what you can see on the surface, on the outside, and then the volume is what can you feel inside. Okay. Is that good? Okay. Yeah, you're welcome. So let's take a look at example 1 and example 2. Go on from there. So example number 1, it says here, using the formula for surface area and volume, find the surface area and volume of the following shape. Now, we know that this is a cylinder, so we're gonna figure out the surface area of cylinder. So how can we figure out the surface area of the cylinder? This cylinder, there's no restriction to it. They're saying that every parts of the cylinder is in here. So what's the formula for cylinder? Okay, let's take a look. Let's flip back. Surface area of a cylinder. SA 2 pi RH plus 2 pi R squared. Okay, so the very first thing that I would ask you to do and get into the habit of doing this is to write down the formula. So 2 pi RH plus 2 pi R squared. So this is the side of the cylinder, and then this is the two circles on top and bottom. Now the next thing that we're gonna do is to substitute the values in, because 1 mark, just to let you know, 1 mark for properly substituting the values in. And I know you can do that. So 2 times pi times R. I gotta figure out the R. What's the value for R? Okay. R is the radius. This one here, they tell us this is 6.5. Yeah, because it's times the height. What's the height? 20. Okay, plus 2 times pi R squared. So 2 times pi times R squared. Again, 6.5 squared. So this kind of question would probably be worth 2 marks, 1 mark for appropriately substituting and using the right formula, and then second mark is for calculation. So why don't you go ahead and calculate that? Why don't you calculate that, and then we'll answer. We'll write down our answer there. Good. I'll do the same. Did you get 1082.28? Yes? Okay, so we're almost done. Now, because we're talking about area, surface area, the unit would be centimeters square. Centimeters square. Anything that's area is unit square. Okay? So that's the outside. Now let's do the volume. So volume of cylinder. Okay, so why don't we go to the formula sheet and figure out what is the volume formula that we're gonna use. So go ahead and do that. Yeah, pi r squared h. Yes. Okay, is everybody okay? Okay, so go ahead and do the substitution properly. I'll do the same. Mm-hmm. 2654.65. Okay, now because it's the volume, how much stuff inside, this one is gonna be unit cubed. Unit cubed. So the unit is centimeters. Centimeters cubed. Yep. Oh, you got a different one? Okay.
How come the volume is bigger than the surface? How come the volume is bigger than the surface? Yeah.
It's not always the case. Sometimes it's not. Mhm. Yeah. Is that okay? Yeah, you tried it now? Everybody got the same answer in centimeter cubed. So 1 mark for, like I mentioned earlier, 1 mark for appropriately figuring out the formula, substituting, and then finding out the answer with unit, that's another mark.
How it become
Hmm?
Why
Y squared?
Why
Y cubed.
Yeah.
Very good question. Okay, so here it is.
3.
R, okay, looking at this one, R. R is in centimeters, right? So pi times 6.5. I'm gonna write down centimeter there and then square, okay? And then height is 20 centimeters. Okay. We already know the answer for the number, which is that one, okay? So that's good. But then looking at the units, let's focus on the units. Centimeter square, that's gonna have centimeter square already, right? And then there's another centimeter that we have to multiply. So centimeter square times centimeter, so that's gonna be centimeter cubed. Because we have a 3-dimensional picture. And we want the volume inside. Okay? So far so good?
Yeah.
Okay. Now let's take a look at B. We're supposed to figure out the surface area of this shape. What do you call that shape? Triangular prism. Okay. So surface area of a triangular prism. So what does that look like? B, base times height, plus length, the whole length there, times the sum of A, B, and C, the sum of the perimeter of the base. Okay? So base times height plus L times A plus B plus C. Now this one here doesn't label the B, the H, the L, the A, the B, and the C, but we should be able to figure that out, right? So this is the B. This is the height of the triangle. and then the A, B, and C, and then the length. Now, does this formula make sense to us? Let's calculate it first, and I'll talk about what that formula looks like and why that came to be. So what does the B? B is the 10 times the height. So this one talks about the two triangles, the front triangle and then the back triangle. Base times height. Height is 12, yes? Plus the length, this length. That's going to be 24 times A plus B plus C. So A, what's the RA value? A is also 13 plus B is 10 plus C is 13. So 10 times 12, that's going to give us 120. Yeah. Plus 26, 36 times 24. 864. Okay, so this times all of that. So the total is 984. So 984, what's a unit? Okay, it's inches. Surface area, squared. Okay, inches squared, or square inches. I don't know which way you want to say it. Okay, now let's take a look at the volume. Oh, I haven't explained why that is the way it is, right? Okay, I'll explain that first before we get into the volume stuff. I need a separate page because I don't want to mess it up. Okay, so let's take a look at one triangle. Remember I said that B, base times height, that's going to give us the two triangles. Why is there no 2 over there, right? If that's for two triangles. Somebody thinking about that? Somebody was asking that question, like, how come there's no 2 if this is a triangle? What's the formula for triangle? Base times height, right? That's a formula for one triangle. So what's the formula is triangle area is 1/2 times base times height, yes? Yeah. But we want two triangles. So if you have two triangles, then you're going to have 2 times 1/2 base times height. Okay, so 2 times 1/2, that cancels. So you're left with base times height. So when you see the B times height in this formula, that actually accounts for the two triangles on both ends. Okay, that good? Now let's see if this makes sense to us. Why is that the way it is? Why is that? Because sometimes we just give you the formula and we'll just say, yeah, that's just the way it is, right? And you probably want to know why that is because you're curious. Okay, I'm gonna start off with this. Okay, 3D picture. Okay, how many rectangles do you see in this one in here? Rectangles.
3. Oh,
Do I even have this picture? So you got these two triangles at the end. So how many rectangles are in here?
3.
3. There are 3 rectangles, right? So these are the 3 rectangles. Okay. So I'm gonna draw on this one and I'll erase it later. Think of this as, this is our 10. Oh, doesn't work. Make sure that it's non-permanent. Yeah, that's a good one. Thank you. So this is the 10, right? This length is 10. And then if I, yeah, going back to our question. So this is 10, and then what would this be? 13 and 13, yes? Mm-hmm. Yeah, 13 and 13. 13, and this is 13. Okay. So see that when we open this up, when we open it up, it, not counting the triangles, I'm gonna fold in the triangles if I can. Okay, I can't. So if you just focus on these three rectangles, so you got 13, 10, 13. So that gives you this one, right? This whole thing. And what is the, this one over here?
10.
This is the 10. So it actually creates one big rectangle. One big rectangle. And how do we calculate the rectangle? Well, length times width. So this is the, well, the length is this one. And then this becomes the width of the triangle, so, or of the rectangle rather. Okay. Now we see why, I hope you see why the formula is the way it is. Okay. So that's that. That's nice props. Now we're gonna get into volume. So what's a volume? What's a formula for volume? Let's take a look. Sometimes I don't remember everything, so I gotta take a look. 1/2 times base times height, of course, that's a formula, times the length. So 1/2, the base is 10, height is 12, times the length is 24. Okay, that I don't know. So you can go 1/2 or 0.5. I'll just go 1/2 times 10 times 12 times 24. Okay, 1,440, yes. And what's the unit? Inches cubed. Okay, so inches cubed. Now you want to put this on your study sheet or formula sheet for the exam. So area and surface area, you're gonna have unit square, and then volume, that would be unit cubed, just to kind of give us ourselves a reminder. Okay, how's that one going? Is that okay? So far, so good. Good. Okay. So I'll give you a chance to copy that down. I'll be right back, okay? Okay. I think we have approximately 25 more minutes. So I'll get started with lesson 6. Is that okay? I still have some people who still have to write the test. The other test. Unfortunate. I'll talk about that in a second. Okay. I think it would be a good idea to just maybe get started with the lesson 6, maybe a few examples. It's really a nice tie-in with what we're doing right now. Okay. Who doesn't have a booklet? Okay. Okay. Now, it's nice that we're going to be talking about lesson 6. At least get started with that. Okay, let's read the question or example 1. Page 33. I'm going to put this into example 1. It says here, the following shape is a grain silo. Okay, I don't know if you've seen that before, but I never really seen this until I came here. And that's basically where they store the grain and all that stuff. It is made up of, okay, they are kind of telling us what it's made up of. Okay.
Aluminum.
A cylinder and a cone. Yeah, aluminum. With 8 meter in height from on top. Oh, okay. So they're saying that a cone with 8 meter height on top. Okay, well, that's kind of nice that they kind of clarified that part right there. Calculate the volume of this composite shape. Okay, good. They gave us a few stuff. And when we read this, calculate the volume. Calculate the volume of this composite. It's kind of nice how they use the word volume, and it's very clear. Calculate the volume of this. But sometimes they don't tell you calculate the volume. They would say like how much grain can be stored in here, right? How much grain can be stored? Well, the grain is stored in the inside, so that calls for volume. So the grain, we have two things going on in here. We have a cone shape on the top and then a cylinder at the bottom. So what we need to do is figure out the volume of the cone top and volume of the cylinder. So let's do that. So volume of cone. Okay. So what's the formula for the volume of the cone?
Base times height. 1/3 pi radius squared times height.
The cylinder looks like a rectangle. How can we figure
Oh,
out?
yeah. Oh, that's right. That's a kind
it was
of
a
interesting thing. Yeah, yeah. So the question said, somebody said, this one looks like a rectangle. How do I know it's a cylinder? Yeah, this one here. It does look like A rectangle. Yeah, but it should be a cylinder.
Because of the cone.
Yeah, because of the cone on top. Okay, and how do I demonstrate that? Okay, how do I demonstrate that? Because of the cone. So this is the cylinder, and then there's a cone on top. That's what it would look like, right? So we can't put a cone on top of a rectangle. Good question. Sometimes you take it for granted. So yes, this is the formula. So let's go ahead and keep going on with this one. So here we go. So 1/3 times pi times, oh, I'm gonna use brackets. I don't like x. What would be the radius here? What do I put in there? 10. Yeah, 10. And how do we know that? Because
We divide into 2.
because here, this is 20. That's a diameter. So if this is 20, then that means this is also 20 at the base. That's a diameter. Cut it in half. Squared. Okay, I gotta follow the formula here, right? 10 squared times height. Okay? We are focusing on the cone. What's the height of the cone?
8.
The 8. Okay, so everything is meters. That's what I forgot to mention is like make sure everything is all the same measurement, same unit rather, same unit. Okay, so go ahead and calculate that piece. $837.76, and that would be in, okay, volume. What's our unit? Unit cubed, so meters cubed. Now we're gonna do the volume of a cylinder. Okay, what's the formula for volume of cylinder? You get pi r squared times height. Now, because we're talking about the cylinder, we're going to use the height of the cylinder, which is 35. Did you get 10,995.57? And the unit again is also meter cube, cubic meters. So now what are we gonna do here? Add them up, yeah, exactly. So total volume excuse me. So, is that okay? No, it's not bad. It's pretty cool. Pretty easy.
It's not like easy, but complicated. Complicated.
Yeah. The key thing here. That's a good thing, right? You're telling me you're pretty honest. Like, yeah, it looks easy. because we're talking about it, right? It's easy in class, and then when we're trying it, like, whoa, this is not as easy.
To remember the
Trust me, I know what that means. I know how that feels like. The thing about this is, you know, it would be helpful if you highlight important stuff, right? They say volume, stuff inside, then
question.
yeah, looking at the question, yeah, reading it carefully, we're going from there. Yeah, I agree.
Understand the question. That is the problem.
Yeah.
You have all for me.
Yeah. Sometimes it's just that, and sometimes it's hard for me too.
To understand the question, English is a big barrier.
That is the thing. That is
Barrier.
A bridge.
Yeah, and that's why when the teachers make the exam,
yeah.
because we are the one creating your exam. Everybody's exam in grade 11 applied. Me and Bisham are gonna do that. We try to make the wording simple. Okay, we are trying to make the wording as simple as possible, right?
Is it understood?
So everybody is like in the same, not gonna have like, what does that mean?
Yeah, man.
Okay, let's take this one here is really, a company makes cement sewer pipes. So, has everybody seen sewer pipes before? No?
Right?
Yeah, a pipe. So a pipe is basically is a cylinder, yes? Okay. Now, a pipe, you want something to go through the pipe. So that means there's a hole inside, yes? Right? Just like the straw, right? It's thinking of that as just like a pipe, but then it's not completely sealed in. It's not completely. So there's a hole inside. So a company manufactures cement sewer pipes. The pipes have a thickness of 4 inches. Okay. Thickness, so that means this thick is 4 inches. I'm going to write this down. So this is 4 inches all the way around. Okay? It's pretty thick. 4 inches is pretty thick, right? It's not tiny. And a hollow. And the hollow part has a diameter of 36. So when we show this to you and you look at the top view, this is the top view. The top view looks like this. You'll see circle and a circle. Yes? Yeah? Because it's a hollow in the bottom. So where is the 4 inches thickness? The 4 inches would be here. And then this is also 4 inches there. Yes? It's because it's thick, 4 inches thick. What else is in here? It says here, the hollow portion has a diameter of 36 inches. Well, where's the hollow portion? That's this part here. This is the hollow portion, and then they said that's a 36 inches. The pipes are sold in 20-foot length. So 20-foot length. So that's the height there. 20 foot. Length. Calculate the volume of the cement required to make one pipe. So how much cement would it require to make the pipe? Remember, the cement is not filled all the way inside, right? There's a hollow portion there. What else do you notice here? Notice that some units are different. So you see inches, you see inches, you have feet. Okay, so when we calculate certain things like that, we have to be consistent. Okay, so what can we do? What can we do? Calculate the volume required to manufacture one pipe. See here. What do you know about feet and inches?
12 inches.
12 inches is equivalent to 1 foot, right? So you got 12 inches is equal to 1 foot.
Do 12 times 20.
So either, okay, they didn't specify some stuff in here. So either we change the inches to feet or we change the feet to inches. Okay, either or. The question is not particularly telling us which way to go. So what we could do is we can change everything into inches. Okay, so if this is 20 feet, how many inches would that be?
1.4.
Okay, oh, 20 feet.
20 times 12.
20 times 12, yes, 20 times 12, right? Okay, so this one here, 20 feet is equivalent to 240 inches. Okay, that's the only thing that we gotta do, right? Because now everything is in inches. So how can we do this? Think of this, a hole in the middle. So what do we do when there's a hole in the middle? Do we add or do we subtract? Subtract, right? If there's a hole, we subtract. So we're gonna do the exact same thing in here. We're gonna subtract. We're subtracting the hole. So we're gonna do the cylinder. So volume of cylinder, I forgot to put volume. Volume of cylinder from the outer portion. The outer portion. Okay, so how can we figure out the volume of the outer portion? Pi r squared times height. So pi times radius. So what's the radius? What's the radius if we're gonna take the all the way on the outer side?
80.
So this is 36, so that means this is 18 and 18. So from here to here should be 22. 22 squared. What's the height? Okay. Did everybody catch where the 22 came from? No? Okay. The inner is 36, so that means it's 18 and 18. So we want to do the outside first. So from 18 and 4, so that's 22. What's the height? Height is 240. Okay. This is going to be a really huge number. Ooh, 927. So 364,927.42, and the unit is inches cubed. Okay, that's the outer part. Now let's do the volume of the inner. Volume of cylinder, but it's the inner cylinder that we're talking about. So volume of the inner is pi r squared times height. So pi, what's the radius of the inner cylinder. Inner cylinder. So we're taking a look at the inner circle. 18. Yeah. 18. Yeah, 18. Yeah, we just want the inner. So that's 18, right? That's a radius. Squared times height. Height is 240. Okay. We're going to use a 240 because everything is inches, right? So pi times 18 squared times 240. 244,290.24. And that's inches cubed. And every time there's a hole, we subtract the whole, right? So you gotta subtract. So total, yeah, volume. So you gotta subtract those two to figure out the remaining volume. And that's it. Yeah, 364,927. So the remaining is 120,637.18 inches cubed, cubic inches. Okay, I think this is the best place to stop. Thank you so much for your patience for this one, and we'll continue on with this next week. We'll finish it up for sure next week. The only thing that I would ask for the weekend for you is for you to keep up with the questions from the book, try them, and yeah, just go through them.